So today's episode is going to be all about engines. And to be more specific, I'm going to be rebuilding this Astra VXR engine, not to standard spec. We're going to be upgrading it. So we're going to be forging the bottom end. We're going to make it around 400 horsepower, if not a little bit more. So you've already seen this engine before in previous videos, and you've already seen the car it's going in. Now that is already a 2-litre 16 valve Vauxhall Nova. On throttle bodies at the minute, and it's 210 horsepower. It's a quick car, but the owner of the car wants it to be even quicker. So the plan is fully forged this VXR engine. So we've got lots of parts, as you can see here. And by the end of today's video, I want to get all these fitted, and I'll get this ready to fit in the Vauxhall Nova. So just go over a few things. So we've got some low compression forged Wozner pistons. We've got NA camshafts. These add a bit more power. Got lots of new parts, such as new coil, loads of new sensors, new time belt kit. Now this is an earlier cam belt kit, so this is from a naturally aspirated Cavalier engine, for example, so it should give us a bit more room in the Nova engine bay. Got a high flow EDS copy inlet manifold, got the Nevlock forged rods. These are steel, nice and light, nice and strong. Again, lots of sensors. So because the pistons are bigger, we've had another block rebored, overboard, and it's had some work. So it's been done by R&D Motorsport. Now, they haven't sponsored the channel, but they have done a very good job, so I want to show you the work. So they've wedged the block. Now, these are open water galleries, whereas like an earlier block, like a C20 let, for example, these are closed and it just has small holes in. Well, apparently these crack when you start running bigger power, so they've put wedges in, which you can see here. Nicely fitted, a little bit of machining, as you can see. It's all being decked, it's been overboard, owned out nicely. So yeah, this wants cleaning up, painting, and then we can start stripping that other engine and putting all the bits onto this. Obviously, we're not going to be using a lot of that engine. A lot of it's going to be either new or refurbished, as you can see here. So first thing I want to do is I want to get this block on the bench, give it a really good clean, paint it up, and then I'm going to strip the other engine and start building it up. Right, so we're just using some standard wire wheel attachments for a drill. We're going to go over the whole thing, get rid of the big bits, then go over it with some sandpaper, mask it up, prime it, paint it, and it'll be ready. Now, I'm fully aware cleaning things up like this isn't essential, and a lot of people won't bother doing it, but I think it just gives it the edge, and it's going to make it look really nice in the engine bay. It's going to look basically brand new, which is what we want on this build. Now, luckily for me, this engine block's clearly not had a lot of use because it's in really good condition. They're generally really rusty, particularly on the front edge, because they're obviously exposed to the elements. This one isn't, as you can see. It's still got quite a lot of original paint on it. So yeah, it doesn't take long to just whiz over it. And I degrease it all with some brake cleaner, clean it all off with a rag and an airline, and then she's ready for some primer. Now I do just use a little masking tape first, just to mask off the machine faces, and then go over the whole thing with some proper professional X primer, followed by some gloss black. So that is the block all painted, and it's been painted for 24 hours, so it's nice and hard now. I've just cleaned up some of the gasket areas a little bit. Yeah, really chuffed with that. It looks really good. So let's get some tools out and make a start on this. As I've already said, I'm not going to be using a lot of components off this engine. However, I do need a few bits, such as the sump and the crank, a few of the bolts, alternator, a few things like that. But a lot of it is going to be renewed. So I slowly started stripping it down, starting with a timing end, and I make sure I put everything down in a logical order, all the bolts together with all the pulleys, so I know exactly where everything went. This just makes it a bit easier for reassembly, rather than shoving it all in one big bucket. I then take the turbo off and all the pipes associated with that, followed by the rocker cover and the water housing on the right hand side of the engine. Now again, a lot of this I will not be using. Once that's off, I take off the inlet manifold, alternator, and the oil cooler setup, including all the ancillary pipes. So we're cooking on gas now. Next job is to take the exhaust cam out so I can take the head off. Now the exhaust cam covers the head bolts. There's 10 head bolts. They come out. I'll start from the outside and work my way in. So we're down to just a short bottom end, as you can see. And I've learned a couple of things from this. So one negative, one positive. Negative, which we can turn into a positive, is this definitely needed reboring. It's got quite a few scores in the bore, and there's loads of piston slack. I mean, obviously I can't measure that, I'm just guessing, but I'm pretty certain it should be that much. So that's one thing. But the Brucey bonus here is the cylinder head has been professionally ported and polished to a very good standard. All the ports are really sharp, really clean, and look really uniform. So very impressed with that, because that probably would have cost about £1,000 back in the day. As you can hopefully see, look how sharp them ports are. Really nice. All of them match. Inlet's also had a little bit of work, but we're going to get rid of that anyway. Doesn't really matter, but yeah, very impressed. Now I will be stripping this head anyway. I'm going to clean it all up. I'm going to change the cams for NA cams, which are basically the same as the fast road cam. Got more lift. We're also going to reseat the valves and just give it a good clean up and a freshen up basically. Now the beauty of these engine stands is you can turn them around. So I spin the engine over, take the sump off and pull out the balance shafts. Once that's out of the way, I'll undo the big end bearings, push the con rods and pistons out, and then undo the main bearings, take the oil pump off, and then finally I can pull the crankshaft out. So I want to do this build slightly different to the standard stuff. I want to use a few earlier parts to make the conversion a little bit easier. Now this is stuff that has been done before, but it's not very well documented. So I'm hoping this video is going to be very helpful. With that in mind, you need to stay tuned till the end to make sure you see every little mod I do. So we're going to be doing a few things like this. So that is the original plastic timing cover. This is a timing cover from an X20 XEV from a Cavalier. Now, physically bolts on the same, but as you can probably see there, it's smaller. And that gives us much more engine mount clearance, which is much better. Because obviously on this, the engine mount bolts here. We want to bolt the engine mount on the front of the engine like you would on a Nova. So we're going to be using that setup. I'm going to show you exactly how to do that. Another thing I want to do, I want to downgrade the pulley system. So it should have a multi-V belt. Now you've got to remember these have aircon, things like that standard. And Nova doesn't need that, it just needs an alternator. So I'm going to be putting a single V belt on. That's a double. I'm going to machine the outside off. So it's a single V. It's going to give us a bit more chassis space because there's not a lot of chassis space on these cars. So I'm going to show you how to modify a Z20, so like a VXR crank pulley, to fit an early style V belt outer crank pulley from, say, for example, a C20XE. And the last thing I want to show you is I did find some bits of metal in the oil pickup pipe. Now these are magnetic. I think they're a bit of a helicoil. I can't really tell. It looks like maybe a thread or something, but it's clearly gone through. Got stuck in the oil pickup as it hasn't got any further. There is some white metal there, which I thought was probably shell material. But I've looked at all the shells on the big end and the mains, and they all look in good condition. So it's not that. Who knows? I'm not overly worried, but yeah, that's why we clean these things out. So next job, I want to clean this lot up. Now we're not going to be using a lot of it, but we are going to be using some of it. I'm going to clean it all up, get it ready, and then I can start rebuilding the engine.
Several days later.
So we are now at the point of engine reassembly. Now I have spent quite a lot of time off camera cleaning lots of parts up, ready to fit. So everything you see here has been thoroughly cleaned and inspected, and I even painted a few bits. So the crank is now ready to go in. Before we can start fitting this crankshaft, there's one thing I need to do. Now, we want to remove the balancer shafts on this engine, just because they're not essential. We don't need them. It's extra weight. It's going to sap a tiny bit of power maybe, and it's just something else to go wrong. So we're going to get rid, but to do that, we need to block the oil feeds. So we've got the main bearing caps here, numbered 1, 2, 3 is in the vise here, 4 and 5. And 2 and 3, as you can see, have 2 oil holes. This is the oil pressure to the balancer shaft. Now these need blocking up. So the plan is I'm going to drill into these with a 6.8mm drill bit, and I'm going to tap them M8 by 1 1/4 standard thread. And then I'm going to put these inserts in these little bungs with some Loctite, tighten them up, and that's going to seal the oil gallery off to the balancer shaft. So if you want to delete the balance shaft on your engine, this is very essential. If you don't do this, you're not going to have proper oil pressure because you've basically got a really large oil leak internally in the engine. Don't be put off by the fact that I've got to do this. It isn't actually that hard. You can use a cheap tap and die set, which is what I'm using to do this. You can get all the bits off eBay very easily. And like I say, just careful, take your time. It's not that hard to do. You can just use a normal hand drill like I did, but I just advise it, make sure you drill nice and square. Don't drill at an angle because that could cause you problems. And exactly the same with a tap. Make sure you tap nice and square. And finally, once I've cleaned the caps up, I put some new grub screws in with a bit of Loctite to stop them coming out. I then put the crank main bearings in, followed by the crank and plenty of assembly lube to make sure it doesn't run dry. Put the main caps on, and then I used some new high tensile upgraded bolts and tore everything down to spec. And that is the first bit of the new engine fitted.
Next job is the oil pump. Now I use a new steel gasket for these. You can get paper ones, but the steel ones are better. Now this is an original ZLEC pump. We wanted to get a new one, but I've been told these are the best of the best. You can't get any better than these. You can't get new ones anymore. You can only get reproductions, which aren't as good. I do take my time to strip it and clean it out beforehand though, just to make sure it's all in good order. And I do replace the oil seal on the end of the crankshaft. I torque it up to spec, and that's another job done.
Next job's conrod and pistons. So steel conrods was the low compression forward pistons. Very nice. So they're numbered 1, 2, 3 and 4. All the rings have been set, gapped by the engineering company that did the block. So I don't need to worry about any of them. I just need to make sure I put the right one with the right one. So number 1 ring, number 1 rod, number 1 piston, gudgeon pin, and then we've got the clips. Right, let's get this built.
And that was as quick as 3, 2, 1. Look at them, don't they look great? Ready to be fitted.
Right, so all the pistons and conrods are built up with piston rings on. Next job is to use a piston ring compressor to compress them in and put them in the bore. So generally, I'd imagine on pretty much every engine you would work on, the inlet valves are bigger than the exhaust valves. So if you don't know which way they go, inlet ones are always the biggest ones, which are here, which on this engine is at the back, because inlet's at the back, exhaust at the front. So put them in that way.
So I fit new big end bearings, put the ring compressor on, lube everything up, and then tap it down with a hammer shaft. I then torque up the ARP bolts, and that's another job ticked off. Now they're on, we move on to the balance shaft delete. Now this is like a griddle pan which bolts to the bottom of the engine, reinforces it, but it also houses the balancer shafts. So I take the circlips, will hold these on, off, undo all the splash shields from the bottom, and then it's just a case of a bit of brute force. I do use a brass drift and a big hammer just to knock these out. They do come out, they are quite tight, but they do come out eventually. I reassemble it, clean it all up, and it's ready to go on. I fit it, torque it all up, and finally fit the oil pickup pipe.
Right, so next job, the crank pulley. Now this is a 4-bolt crank pulley, early one's a 6-bolt. So I need to convert that so I can fit an early single V outer pulley. And I've discovered that 2 bolts line up. So in theory I could just use 2 bolts to tighten it up. However, I want to do it better than that. So this is like an interference fit anyway. So I'll put a couple of bolts in. And then I'm going to use the transfer punctures to centre them, drill the holes, tap it, and then I can put 6 bolts in.
So for those that don't know, a transfer punch is a punch which is designed to fit tight inside a machined hole like this. It's got a little centre on the inside of it, and it will find you the perfect centre every time. You get a set of about 30 of them, come in all different sizes. You find the right one that fits, and away you go.
Now these are going to be very close to these little cutouts. This may be a little bit sketchy, but I'm going to give it a go, see what we can do.
So I started off by drilling a 4mm hole. There's like a pilot drill in each of the centres. Then I move on to a 6.8mm drill. Again, this is for an M8 tap. So this is the correct size for a standard M8 by 1 1/4 bolt. So we're 13 minutes into this video, so I think you guys must be enjoying it. If you are, there's a couple of things you could do to really help me. First thing, subscribe to the channel if you haven't already. Second, like the video. And third, and probably the most important at the minute, is the new hype feature. So doing this stuff is all completely free, but it will mean a massive amount to me. I spend hours and hours and hours on these videos you would not believe. So if you want to thank me, do any of the free, or if you really want to thank me, do all free. I just want to give a big shout out to all the people who have already done this and helped the channel grow to what it is today. So a big thank you from me.
Right, next job, I've taken the crank pulley back off. I'm going to try and fit the early 16 valve Cavalier timing belt cover. So, differences, on the earlier engines, these are M8 bolts, these are now M10 bolts. So I've had to drill this out. Now this is a C20XE idler bracket because I'm ditching this. This is the original setup, don't want to be using that. And that basically replaces this, but obviously don't have the engine mount built in. So I've drilled these out. I'm using the bolts from this. I should be able to fit like that, like so.
Another point that I probably don't make enough, if you guys ever have any questions about anything I'm doing here, just ask in the comments. I do reply to all messages. Now these brackets did originally have M8 holes. I've drilled them to 10.5 mils so I can use 10mm bolts through it. Now I'm using X20 XCV pulleys and belt setup. Now the idler pulley did have an M8 hole in it, so I had to re-drill that. I did try and use a Z20 let pulley, but the offset was slightly different. It probably would work, but I wouldn't recommend it just in case it causes issues. I fit a new water pump, torque everything up, and then I start fitting a few other bits. So I put a few brackets on and the sump upper and lower section, and again torque everything to spec using new gaskets.
So next up, the head job. Now, I hate doing cylinder heads, I'm not going to lie. I find it very boring, time consuming, but it does need doing. Now, like I said, this head has had work previously. It's definitely been gas flowed professionally. And these do suffer with valve oil stems leaking, and there's no evidence of them leaking. So what I'm going to do, because I don't want to take all the valves out if I don't need to, I'm going to just check all the valves are holding fluid, and if they are, I'm happy with the stem seals. I won't bother, I'll just clean it up. I've taken the lifters out and cleaned them, but again, they're in really good condition. Although it might look a bit tight and a bit dirty, I think this head's in really good nick. So yeah, we're going to test to see if they leak off. If they do, I'll then take the valves out, lap them back in, but if I don't need to, I won't.
So I use brake cleaner to fill the chambers. I use this because it's really thin, so hopefully it will show the leaks.
Now I can't see anything in there. Now bearing in mind I'm using brake cleaner, which is very thin and will find any little tiny gaps. The exhaust side is definitely good. Levels maintaining, as you can see they're pretty much fully submerged. Inlet valves aren't, but it's the exhaust valves that normally cause a problem because they get hotter, inlets don't. So generally when you have to reseat them, it's always the exhaust valves. And they look nice and dry too. So with that in mind, I'm just going to clean this up, give it a lick of paint. So just checking it's true, and that is really good. I'm really pleased with that. Perfect.
So luckily for me, although it's a little bit dirty and oily, it's not in bad nick. So I just use a wire wheel on a drill, selection of a few different sizes, and that does the job.
So one thing I have noticed is there's a broken stud here, broken bolt. So I'm going to put a washer over the top. I'm going to weld the washer to that. I'm going to weld this nut to the washer, and hopefully that is going to come out.
Now I didn't actually need to use a nut in the end. I managed to work the washer free with some grips. Now this is a tried and tested method, and it works very well.
All cleaned, painted and ready to be fitted. I've also blown out all the bolt holes just to make sure there's no shrapnel in there, no oil or anything like that, because that could hydrolock the bolt. And I've put it on TDC, so number one's on top dead center, head gaskets on, and the dowels are in, so we're ready to put it straight on.
So after carefully lowering the head into position and making sure it's locked onto the dowels properly, I used brand new bolts. Now, general rule of thumb for head bolts is you start from the center and work your way out when it comes to torquing. These are 3-stage torque, and if you want to know any of the torque settings or figures, just let me know in the comments and I'll happily tell you everything I know. One thing I will say is these Vauxhall engines do have a 3-stage 90-degree setting, which when the engine is on a stand like it is a bit of a pain to do because it wants to move all the way around. If it's in the car, it's a lot easier. Now that's all done, it's time to start fitting some of the coolant housings. So I put the thermostat housing on and then this coolant housing on the end of the head. Again, I bolt everything up and torque it to spec. I then fit a brand new coolant temperature sensor because these are known to fail occasionally, making the engines run rich. So we can do that while we're at it and fit the rear coolant housing as well. Again, all brand new gaskets on everything we fit. I fit the refurbished bleed hose on the front of the head. I'm not sure if I'm going to keep this yet, but it looks good for now. And then I fit the EDS style inlet manifold to the rear of the engine. I used all new fittings on it. It looks pretty good if I do say so myself. Once torqued up, I fit the brand new fuel injectors. Now these are 660cc injectors, and they should be more than capable of making the 400 horsepower power figure we have in mind for this engine build. Now I will say they were quite tight to fit, so I used some clear silicone lube on all the seals just to help it all slide together. And then I used the VXR fuel rail and some brand new fittings to hold it on. I put a standard union back in so we can use a standard style fuel hose. I fit the VXR throttle body with a new gasket along with a brand new top part. Now this is an upgraded aluminium piece, should just help unlock a few extra horsepower. And finally I fit the standard brake servo takeoff from the original manifold, which just screws on underneath. Now the inlet's done, we bolt the starter motor on. Now you can only put one bolt in for now, but that'll do just to hold it into place.
So as you can see, this engine is definitely getting there now. But the main thing we still need to do is fit this turbo. Now this is a reconditioned KRS Stage 2 turbo. Now if you know anything about Vauxhall tuning, KRS turbos are one of the biggest in the game. They make some great turbos for these engines which produce really good power. So this is a Stage 2 turbo. I don't know exactly the specs of it, but I do know they're very good and they're rated up to about 400 horsepower, which is very impressive. It's still a pretty much standard size turbo from what I can gather. So let's get this fitted to this. So there's the old turbo, there's the new turbo. Now from what I can gather, this is a bigger compressor housing. I think it's got a billet compressor wheel and a few bits like that. I don't know the ins and outs, I just know they're good for 400 horsepower, which is exactly what we want for this build. I know the actuator is being upgraded and all in, the quality looks excellent. Even little things like this is machined the edge of the inlet. So it's just nice and smooth. Like the original, which looks like that, not as nice. So we need to swap the pipes over from this to this and probably just give them a bit of a clean up because they don't look the best.
So I take everything off and spend a bit of time just sanding everything down, cleaning everything off, ex-primering it and painting it. I just think the attention is in the detail with projects like this. If you leave them rusty, it just kind of spoils the look of the car.
Right, so that's everything off and cleaned. Now I have painted everything or cleaned it up, so I've flushed out all the oil lines, so they're all nice and clean now. No restrictions in them. Got a new plug for the top of the turbo, so we're going to put that in first.
Now, I never used to really like building engines, but I will say I do find this very therapeutic. Making something which old and rusty look brand new again is very rewarding and I do very much enjoy it.
Turbo oil feed, again, I've cleaned out the banjos, cleaned out all the lines, so we know she's spot on.
So the oil feed was a bit of a pain because the wastegate is bigger than the old one and the bracket is slightly different. So basically I couldn't get a socket on, so I had to undo the wastegate to get this fitted, but we got there. Once that was on, was plain sailing. It was a case of putting the water pipes on. I used new copper seals on absolutely everything just to make sure we're going to have no leaks. And that's pretty much all the water pipes done. And then finally, after put the securing bracket on, all we had to do was fit the oil return. Again, I used a brand new seal on this because, again, we didn't want any leaks. And that's the turbo ready to fit. So you probably get the idea now. Again, new gaskets, new studs, new nuts, the lot. Let's make it nice. So they're not the original fittings. They are just normal, universal aftermarket exhaust parts, which you can get readily available from most places, but they do look loads better than the old original rusty things. I bolt the oil feed to the block and I also loosely put the oil return on. The plan is I'm going to crank this engine before I start it properly, make sure it's got good oil pressure, and make sure the oil is running out the return before I actually start it properly. That way we'll know there's oil to everything and the turbo is primed. Next job's the NA cams. Now these provide a little bit more lift than the standard cams, so should help with a bit of extra power. Again, put a new seal on this and taught everything up to manufacturer's spec. I also make sure there's plenty of lube on it so it doesn't start dry. So it's the same part number for the inlet and the exhaust cam, so you can put them in any order you want. Just make sure you get the timing bang on. Next job's to put on the brand new rocker cover with brand new stainless steel fittings. Now this is a bit of the engine you're going to see the most, so it wants to look right in my opinion. And then put brand new spark plugs in. Torque them up, believe it or not, to manufacturer's spec. I don't think I've ever torqued spark plugs up before, but because I had the torque wrench out and I knew the setting, I figured why not. Again, reliability is going to be key with this build as it's not for me, so we fit a brand new coil pack just in case. Again, torque is down to spec. So we've ditched the standard water to oil cooler and we're going for an aftermarket remote air to oil cooler. So I take the standard pipes off and I fit these unions so we can put aftermarket hoses on, followed by a brand new genuine GM oil filter. And finally, we finish it off with some new silicone oil breathers. One for the front, one for the back, and obviously some new Jubilee clips. And remember, because it's turbo, you need a one-way valve in your breather line. So we are pretty much there with this engine, but we are missing one key feature, and that is the timing belt. So as I've already said, this is going to be an X20 XEV timing belt setup, and it's also got X20 XEV inlet and exhaust cams in, because that's meant to add a little bit of power. One thing you can do to maximize the power is to retard the inlet cam 7 degrees, similar to what you do on the old C20 LETs with the XE inlet cam. So we've been waiting for a vernier pulley to arrive so I can dial it in. It's now arrived, so let's do it. So here is said cam pulley. Now this is the standard one, this is a vernier one, meaning you can move it 20 degrees either way. You can see that. But the problem with these pulleys, these are QED pulleys. These are actually for the X20 XEV as well, believe it or not. They don't say they fit a Z-LED, but they do. Not so convinced the exhaust one will, because I think the exhaust one has like a pickup ring for the cam sensor. But the inlet one is the one we want, and that will definitely fit. So, the problem we've got is these don't have any timing marks on. And yes, you can dial this in with a DTI gauge with the cam cover off. However, it's one of them things, once you set it to 7 degrees retarded, you don't want to really mess around with it. So you want the timing marks to align afterwards, in my opinion anyway. So what I'm going to do, I'm going to modify this slightly and match the original timing mark so we know exactly where it needs to be as a reference point. And then we can set it to 7 degrees retarded. So as you can see, I've unbolted the cam, split it into 2 pieces, and my plan is to put a center line directly down this. So we've got a reference point. So we know that when this is set to 0, that is bang on 0, which is what we want. So as you can see, there's nothing to line it up at the minute other than I, which I don't really like. So I'm going to put a proper center line in. So I'm literally just going to use a straight edge and a Stanley blade to do that. As you can see, that is bang on in the middle. So we can now clearly see, for example, that is set to 0 degrees. So next job, I want to replicate this original mark here, the timing mark, and put that on here. And what I have found with these before is they don't always line up, so you'd think that would be perfectly aligned. And as you can see, it's not quite aligned, but that is bang on. When I did the last engine, it's exactly the same. The pulleys weren't quite lined up. So don't be too worried about that. Next job, I've aligned these up, as you can see here. That's a little mark there. You can just see, I need to replicate it on this one here. And on these, as you can see, it's not centralized, it's on the edge of the tooth. So I've just put a little score mark there, any little one, and then I'm going to use a file to replicate this. Just like so. And there we go, that is now retarded 7 degrees, as you can see. So that's 5, 10, and it's kind of just about in between. So pretty much 7.5 degrees. Perfect. Right, so next job, I'm going to put these pulleys on, get the cam belt on, get it all timed up, and then we're pretty much done. So we put both pulleys on and just make sure they're lined up, and then we put the new cam belt on. Now the trick to this is you want all the slack to be on the tensioner side, so the guide side is really tight. So when you do tension it, it doesn't pull the timing out. Now it's a little bit fiddly to do this and can be a bit time consuming, but with a bit of patience, we do get there. Now the belt's on, you've got to tension it. So you turn the tensioner clockwise until the little arrow lines up with the little slot. Then you lock off the 30mm bolt that holds it in, turn the engine over a few times, check that all the timing's bang on, and then I finally just taut everything up one more time just to make sure everything's nice and tight. And that's the timing side of things all done. And finally, the outer cam belt cover. Now this is a reproduction cover from eBay, they're readily available. It does have 3 holes in here, and what I've done, I've just glued some grommets in, just fill it up to make it a little better. I didn't really like the idea of having 3 holes. I've used a combination of C20XE belt cover fittings and Z-LED ones, and I think we're about right. It's not perfect, but yeah, I think it's going to work. We do have one missing, we need to get one more, but yeah, this is pretty good to start off with. So I'm going to put this on now, screw it up, and that is pretty much it. Now I actually managed to make a final fit in. It's not quite how Jeremy expected it to be in the first place, but it did the job. So I used a bolt and then I put a couple of nuts on the back just so it can be over tightened essentially. And then I just put it through a grommet and it just holds it into place nicely and does the job.
Right, so that is the VXR engine completely built. Now, one thing I will say is this style of video, I've done it slightly different. Normally I'll do this over a few episodes, but in today's video, I've done a month's worth of footage. We've got the dirty old engine and basically we're finished with a brand new looking engine ready to be fitted. So if you like that format, let me know in the comments. Another thing, if you've got any questions, you want to know any talk sense, anything like that, again, let me know in the comments and I'll try my best to reply to every question. So, I'm going to ask you to do 3 things. If you've got this far in the video, please hit the subscribe button, like the video, and hype the video. Hype is a new feature. It helps small up-and-coming channels grow and get noticed. So please do that for me, and stay tuned for more. In the next video, we're going to be putting this in the Nova GSI. And one final note, if you like the t-shirts, we do have these for sale. Let me know again in the comments. See you later, guys. Bye-bye.